everyone, and thank you for joining us, and welcome to our latest DZone webinar in partnership with Instaclustr. My name is Jason Cockerham, and I'm the Community Engagement Manager here at DZone, and we're glad you're here. We've got a really relevant and an exciting topic for you today, and so we're just glad that you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and really anyone passionate about software development. We've got everything from ref cards to trend reports and thousands of articles written and published by our community. And all this makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one, and you can find them all at dzone.com/events. We've got things like fireside chats, virtual roundtables, and who knows, you might even see us in person at an event sometime soon. So be sure to check out dzone.com for all that information. Today, we're talking about PostgreSQL. More specifically, about the benefits of using ANF storage when building PostgreSQL servers. As we all know, support, speed, and availability are crucial for efficient database management. And in our world, most of the time, that means paying a lot more than you want for the privilege. Well, today, Will Stowe and Chris Carter of NetApp are going to walk us through Instaclustr's open source ANF storage solutions for building PostgreSQL servers. Will is the manager for NetApp Data Platform and has been with the company based in Austin, Texas, just down the road from yours truly, for over 11 years. He and his highly skilled data engineers develop solutions for modern data engineering. And like any good Austonian, or even Texan for that matter, he enjoys the art of barbecue. And he did promise samples for everyone attending, so we'll see how that turns out. Chris Carter is the product manager for NetApp, and aside from his extensive technical experience, he is a skilled 3D printer and keyboard designer, which we might have to dive into a little bit more later as well. Here at DZone, we are all about community, so we encourage you to check out all those great resources on our website, get involved with our community. There's a lot of great other people talking about these kind of things on our website, and so you can join in that conversation and be a part of contributing to DZone. So at this point, I'm going to stop talking and turn it over to Chris. Chris, take it away.
Thanks very much. G'day, guys. We're talking about PostgreSQL running on Azure NetApp files. This is a product we've been putting together at Instaclustr for the past year or so, I'd say. Will, right? We probably kicked it off about a year ago, and it's been released for a couple of months, running really well. So Instaclustr, for those not familiar with us, we will help you run your open source software. We don't sell licenses, we don't lock you in, we don't try to open core you where we'll upsell you on little features that lock you into us forever. We run pure open source software and we run it really well. And if you're ever not happy with us, you've just got open source software. So you take it to someone else or you run it to yourself. So what I want to do today is we're going to create one of these clusters, PostgreSQL on Azure NetApp files. We're going to connect to it, and then we're going to talk a bit about how exciting those results are once you do that. So this is the Instaclustr console. Here's one I've prepared earlier. And if you want to create a cluster, you just hit the Create Cluster button, surprisingly. So we'll give it a name, Test Cluster. We're going to give it production SLA. So Instaclustr will fully monitor your cluster. It's all wired up. We're checking CPU health. We're checking whether you're going to run out of disk. We're checking a whole lot of bundle-specific metrics, what's the read, what's the write, are things slowing down, tables chugging, all of this thing. And you can see we support quite a variety of open source software: Cassandra, Kafka, Zookeeper, Cadence is all the new hotness. Everyone doing workflow engines coming out of Uber there. But today, of course, we're going to get the old elephant themselves, Postgres. So Azure NetApp files, you'll be shocked to hear, runs on Azure, right, Will? This is where we've actually got NetApp hardware in the Azure data centers, not just running some software interpolation layer. This is the real deal, and this is what makes this thing fly. We hit next. We've got our setup. You can choose some older versions of Postgres if you want to. We're going to go with the latest new hotness, 15.4. We will be supporting 16 soon, so Postgres 16 is releasing this week. It's right around now. So we will be supporting that within the next month or so. Obviously, we need to put my firewall, my IP address into the firewall. We're going to turn off encryption because otherwise I've got to do downloading circuits, certs, etc. There's a few options depending on how safe you want your data to be. And you can run PG Bouncer. So if you want to do multiple connections to your database because you've got multiple clients, PG Bouncer just helps you pull those connections and create just one connection to Postgres. Choose where we go. We've got obviously lots of different. I'm going to chuck it Australian because I'm Australian. Choose where the network goes. So this is running in Instaclustr's account. So this is a pure SaaS model. The PostgreSQL will run in Instaclustr's Azure tenant. You can, if you want, set it up so we can create the hardware in your tenant. So then you pay Microsoft directly for the infrastructure with whatever sweet deal you've got worked out with Microsoft, which is sometimes better than us if you've got real big contracts. And it consumes your Microsoft Azure credits if you're into that kind of scheme. And you just pay us to manage it for it. So you let us get some hooks into your tenant, let us create, destroy, and manage those clusters. And you only pay us purely for the management of the infrastructure, not for the infrastructure itself. But here we're putting it all in Instaclustr. It's SaaS. You just get an IP at the end and use it like any other Postgres server. So here we go. This is all our options. We hit accept. This is off-the-shelf rack pricing kind of thing. If you come and talk to our sales team, you might be able to do a little commitment, get a little discount on that pricing. And it's that easy. We're now setting up PostgreSQL on ANF, and this is not impossible to do on your own. Certainly, it's open source software with generic cloud hardware, but it's not easy, right, Will? Trying to get ANF spun up with a PostgreSQL.
Yeah, there's like Chris mentioned, we're taking Legos and we're making more interesting products with those Legos. In this case here, you could absolutely stand up Postgres on your own with Azure Nano Files inside of Azure and run that in IaaS. We have customers doing that today. The beauty of this is that Instaclustr is able to manage that environment for you top down. So you're able to get that, as Chris mentioned, as a SaaS offering. We have the custom things we've done in terms of configuration, management, some performance tweaks, those kind of things to get the most performance out of this configuration as you can get. But yeah, anyone can stand this up. But again, highly recommend looking at this from a managed service, because the beauty of this is you can stand up this cluster, additional clusters by way of the web UI here or your automation tool of choice. And have those running at your disposal for any need you may have. Another thing to touch on here as well, while this cluster is building, is the question maybe will come up of why Azure NetApp Files versus traditional disk. And the answer to that is that with the way Azure NetApp Files provides storage performance, it does it in this case here over NFS. We're presenting that right to your clustered nodes, and we're able to get extremely high performance, very low latency, and very high performance of that storage. When you lay a database over top of that, you're able to just naturally get better performance, better throughput, higher transactions per second by leveraging effectively a better Lego again for this configuration, so that when you deploy Postgres and you're running your database on there, you have lots of very busy transactional system, you're going to get more performance pound for pound than you would with a traditional Azure native solution, or even running it on your own. You'll get the fully managed environment, best performance, and all the features that come with that as well.
Yeah. And like not just pound for pound, but some customers have told us like it's actually impossible for us to move to the cloud. The cloud isn't fast enough. Well, if you can find the right Legos, as it were, sometimes the cloud is fast enough after all. You wait till we get to my favorite graphs a few slides down. I'm looking forward. I do have a one I prepared earlier, as it were. So here's basically the same cluster here. Show you a little monitoring, so you can look. I haven't used a whole lot of disk there. There's 0.1% of CPU. We're not really blowing the doors off this, but we got a nice little connection info button, so we can connect to our cluster. Don't try to steal my password for me and mine Bitcoin. It's all firewalled, and it will be deleted. It will be deleted as soon as this webinar is finished anyway. So we just copy the connection string, chuck it in there, bang. It'll ask me for the password, which is there. This will also get TTL'd, so you have to reset that password yourself within 10 days, or we're going to delete it, and you'll probably have to recreate your cluster. We can sudo and fix it for you if you really want. And then, bang, we've got ourselves a Postgres server. So we can head over to schema. Just copy pasting, not the fast. I'm good at designing keyboards, but I'm not the fastest typer in the world, so I'm not typing that fast. There we go. There's a nice table. Chuck some data into it. So, none of this is too impressive, but I'm just showing you this server, and the other one will probably be finished before we finish this webinar. It takes about 10 to 15 minutes to fully provision and install.
Yeah.
We can now select star from sample table where age greater than 29, 27, my age a little while ago. And then we put a semicolon in because that's how Postgres works. Bang, you got yourself a Postgres. It's that easy. So you can wire your app to that. If your app uses a normal SQL database already, you can wire it up pretty quickly and it works. If you're using PostgreSQL, it's obviously very easy. If you're coming from MySQL or Oracle, there's differences, there's tips, there's tricks in how PostgreSQL works compared to that. But same with any SQL database. PostgreSQL is one of the most popular. I think it was the most popular or the most loved database in Stack Overflow, possibly just behind Redis. It sort of dices with Redis back and forth. Redis is obviously a pretty different kind of, it's more of a cache than a database. So PostgreSQL, really popular in part because it's so extensible. So PostgreSQL, you can extend it with Python, you can extend it with Java, whatever code. You don't have to learn some domain-specific language. Whatever you're used to coding in, you can create your routines and your runtimes and your extensions just in whatever language you want. And because it's open source and there's a whole community about it, there's 1 billion extensions that you can possibly install to turn it into a geospatial database. To turn it into one of the cool ones that everyone's talking about right now is PG Vector, which lets you do large language model embeddings, which are obviously super hot right now. Turn Postgres into this data store for all your vector embeddings. Some of our guys internally have used that on our service to create a large language model using Llama, the Facebook open source one, I think. And Postgres is always all you need. You don't need something huge and modern and cool and new. PostgreSQL is so extensible that it can form the basis so that you can train your own large language model. So that's it. That's where we go. We've got a whole lot of options. We'll back up and restore it for you. We take backups every day. You've got 24/7 support if you need to check. Yeah, there you go. So you can talk to TechOps anytime you want. Included in this cluster is a 24/7 helpline. You talk to our guys. They're Postgres experts. Some of them are Postgres committers. Like, we actually employ people who have committed to the open source project, so they really, really know their stuff. They follow the sun. So we've got a 24/7 roster with those guys, and they're there to help you fix any problems you might have with the service. Firewall rules, it's super easy. I loved it because I spun this cluster up at work and I hit add my IP address to the firewall, and then I went home like, I'm not going to be able to connect from home because the firewall let me in. Just a little button there goes add my current IP, and then I'm all set for this webinar. So let's talk about the exciting bit, hey? My favorite graphs in the world. I've been dining out on these graphs internally for 6 months. I started showing that to VPs. I started showing that to heads of departments and whatever. Everyone loves these. So this is what happens when you put PostgreSQL on ANF. So all of these clusters, we've got a standard Instaclustr Azure, we've got a competitor cluster, and we've got our new hotness. All of these are running the exact same core count, the exact same memory on the exact same compute. All we've done is change the underlying storage and run it through a benchmark suite. So you can see we've got nearly double the speed in the read-write performance. So this is sort of a normal online transaction processing database workload where you're reading, writing, and we've gone from around 2,000 transactions per second at the high end up to 4,500, so more than double. And then if you're doing read-only, which is often, write once, read many is a pretty common workload. So this is read-only, but if your workload is biased towards just reading data out because your app needs to grab whatever it's grabbing to process sort of thing, we've gone from 4,000 transactions per second, where you can see that seems to be hard locked just by the IOPS of the underlying hardware. We can jack it up to 17,000. So if what you want is transactions per second, these clusters cost a little bit more. It's premium hardware, so you pay a little bit more. I'm sort of talking in the order of 10%, maybe 20% more, but you get 4 times the performance out of that. So this is the hotness of Azure NetApp Files. This is why we've been working so hard to build this product for the past year, is that it really allows you to do things with PostgreSQL that you can't really do on generic cloud hardware. Pause to regret not pouring myself a glass of water before this webinar.
Yeah, just to pile on there, in terms of this is what we're talking about in terms of Azure NetApp Files, comparing it to other storage systems that are available to you in public cloud today. The differentiator here is our partnership with Microsoft. Building Azure NetApp Files is a jointly engineered program or service from Microsoft, but it's their service at the end of the day. It's an Azure native service. So as we're using this service here, if you're an Azure customer today, as you deploy these services inside of your Azure account, you can use this to go against your Azure monetary commit inside of your account today. You can spin this up and have it running in there in just a few minutes and be able to deliver insanely good performance for your Postgres workloads by using this as a managed offering inside of your account, backed by Azure NetApp Files to solve some pretty cool challenges.
Yeah, And so what we've been working on, this is like hot off the presses literally yesterday, so the graph looks a little Python-y rather than me fancying it up. But we wanted to sort of like, how far can we push this thing? So you can't, this is not available on the platform yet. We've sort of done a little bit of custom tomfoolery on the back end, chucked it on a 32-core machine. So this is like for like, just to compare to ourselves and our competitors. This is us just really trying to stretch its legs and really make this thing run. So we got ourselves a 32-core machine to just get the biggest hardware they have. We've chucked it on a 16 terabyte drive. This is only premium as well. We're talking about putting it on ultra ANF storage sometime in the next quarter or two. We'll see where that lands on the roadmap. And we're looking at like close to 80,000 transactions per second. I think that if you look at the numbers behind this, it caps out at 76.5. It's around there, which is like really huge numbers for PostgreSQL. This is unusual that you would need this much speed, but I just really wanted to get the biggest number possible to show off. So this is hot off the presses. We're working at building, slightly custom configured, but we're working at building this into the platform. That's the other advantage of doing it on the platform, is you can, again, this is all open source, you can get this speed out of it, but to make PostgreSQL play nice with ANF and to play nice in an Azure environment, etc., there's quite a lot of config tweaking that you have to do. We've obviously taken care of all of that. So as soon as you hit that create cluster button, all your config tweaks are set up, ready to go for the environment. To get the best possible speed out of them. If you need to change those, we can change those for sure, for your app specifically, but we've done our best to performance tune these things to within an inch of their life to really get some great results where we are.
Yeah, I think contrasting this real quickly, Chris, that point there, and you'd shown this in the console a minute ago, right? When you look at the other offerings, in cloud offerings in general, not picking on anyone in particular, but generally speaking, cloud offerings are done as a platform-based offering, where you need the support for that is effectively red light, green light. Red light, the service is down, green light, the service is up. But if you're having problems inside the application itself or with the service itself, I mean, how do I tweak a database table? Or if I have questions about migrations or supportability, this is where Instaclustr really shines, because not only are you getting the best of breed in the managed platform, like we're showing here with Postgres on Azure NetApp Files, squeaking out all the performance that can be done and then some, but also being able to leverage that same point of contact for any support issues inside the application therein. Obviously, we're supporting red light, green light like everyone else is going to do, but we actually go one step further of providing application support and migration, consulting services, those kind of things. So you can use Instaclustr for really runs the gamut in terms of all the requirements and challenges one would have, moving from one open source technology to another, or from one cloud to another, or from a proprietary database to open source. We can lean on Instaclustr by NetApp for all those things.
Yeah, absolutely. We've done these kind of migrations dozens of times, so we know what we're looking out for, and that can be all part of your onboarding experience. We also have, we have red light, green light is the cluster up, is cluster down, but most of the hyperscalers, that's it. That's all you get. It's up, and like, can I talk to it? Who cares? Is it running quickly? Who cares? It's just like, it's up, our job's done, the rest of it's your problem kind of thing. Instaclustr will guarantee SLAs on read speeds, write speeds, will guarantee that the cluster, that you can actually write to the cluster. That's all in our SLAs, depending on which bundle it is. So we go a good step above just a basic, Postgres on Microsoft Azure to really make sure that you get a bulletproof solution in the cloud. So I wanted to talk a little bit about the roadmap. So Azure NetApp Files does two cool things in my mind. Will, you might tell me that it does 1,000 cool things because you've worked with it for a lot longer than I have. But the first cool thing is it's blazingly fast, which we've gone through. But the other cool thing is the way that it can snapshot and just like sling data around your NetApp account without you even noticing it. So what we're doing right now, and this is going to go GA sometime this month, is these ultra-fast backups. So a traditional Postgres cluster will use PG Backrest for backups, which is absolutely fine. It is, the open source default solution, but it does mean that it's streaming, terabytes of data here, there, and everywhere, which can be somewhat time-consuming. So the cool thing about ANF is that you can just take snapshots on the drive itself. And then if your app goes haywire and little Bobby Tables drops all of your data and it's all gone, you can just reverse to one of those snapshots in the time it takes to create a new cluster. So rather than finding 4 terabytes of storage off-site somewhere that you've then got to stream back for the course of hours, and I've never been a DB administrator, but many of my colleagues are, and it's like, that's not a fun experience where people are yelling at you, where's the program, why hasn't the database come back up, and you're there for 4 hours watching a little bar fill up as the data slowly streams. The NetApp file snapshots is like, it's instant. So the data's already there. All we have to do is create a new Postgres from that snapshot, attach it to the storage, and you're good to go. So I'm looking forward to that, because that's just, that's the default operational nightmare, is I've lost the database and I need to restore a backup. And this lets us do a snapshot backup, within 10 minutes. Like this cluster that we spun up at the beginning of the webinar, it's already running. I don't quite know when it started, but it's already going. So we could have done a snapshot backup and taken an old set of data. The other cool thing that lets you do is you don't have to just restore to the same cluster. You can actually fork a split cluster. And so you're going to be a little bit careful with this, depending on your data privacy rules, etc. But some of the use cases we've looked at is you might want to put it in your CI/CD pipeline. So every time you develop your app, you might want to do a bunch of operations to your database, and you don't want to do that on live customer data, because you don't want to just scramble up customer data as part of testing your new ticket. But you can create a new database, again, in like 5-10 minutes with all the live data in it, because sometimes it's difficult, I know, to create like synthetic data, or at least I've had applications where it's difficult. Like we tested in pre-prod, but there's nothing really there to test on because there's no one doing anything. So you take a copy of the database, you fork it, you can plug your CI/CD pipeline in it, you can create things, you can delete things, you can check that, check all your rules and regulations work, etc., and then you get the result out at the back end that you're expecting, and you can just blow it away. Like, you pay to spin it up, you run it for 10 minutes, you pay, a couple of cents for those 10 minutes, and then it's gone until you next want to deploy, and you can run it all again. So that one's really cool. That should also be coming sometime this month. And yeah, it'll give you powers. The other cool thing about database forking, and I used to be a data scientist, so this one's quite appealing to me, is like people don't really like data scientists touching their prod databases. They get real nervous that I'm just going to do like select star from star, join with star on star. It turns out that slows down the transactions, because I don't.
Not a good idea. Yeah.
Not a good idea, as it turns out. But if I can fork my own version of the database, I can play with it to my heart's content. And if I accidentally drop a table, or I change everyone's birthday to the 1st of February 1991, then that's fine. I've got my own copy of this database. I can play with it. I can do analyses. I can do fancy regressions. I can build large language models on it. Whatever I want to do, I've just got a copy of the database, and I could do that. I could do that at 7 a.m. every morning. So I've got a fresh copy of the data every morning to play with if I want to run my analyses, and I don't have to touch the production database. So there's some cool things you can do when you can just like fork a data in an instant, rather than streaming terabytes of data from one side of the DC to the other and waiting and paying for network costs and blah blah blah. The instant forking you can do on ANF, also very cool. And then the last one, this is one of the like longer term roadmap items that we'll get to sometime this year, maybe next year, probably next year, to be honest at this point, is ANF can actually stream data between regions in this way. So you can mirror the hard drive that you've got on your primary PostgreSQL server in US East, and you can mirror that over to Australia if you want, or pick somewhere that you think is stable and where your customers are, etc., and then just pay for the storage. So rather than having multi-region replication where you've got two full PostgreSQL servers talking to each other in multiple regions, in case one region drops down, you can fail over to this region, and then you're paying for compute, you're paying for storage, you're paying for monitoring, you're paying for the whole shebang over in this region, when it's just for that once in every few years when Azure kicks over a power cable and the whole DC goes down, and it doesn't really do anything other than cost you money floating over there. Once we've got this disaster recovery set up, we can just mirror your storage over there. So it's a database, its job is to store data. So we don't need to pay for expensive compute. We don't need a 16-core Burley machine doing all of this work. If we can just mirror the data over to the new region, then in that event of disaster where the whole data center goes down and your database is lost, again, it'll take us 10 or 15 minutes to create a new Postgres, attach it into the storage over in Australia, and then you point at the new IP, point your app at the new IP, and you recover from disaster, in less than an hour. Hopefully, other things are probably going wrong when a whole DC fails, but that's an option to get you back up and running in a minimum of time as possible. whilst also not making you pay for twice as much infrastructure that you never ever use. So I reckon that one's going to be pretty exciting when we get it to land as well. But it's a slightly more complicated one, so we've pushed it down the stack a little bit. So that's it. That's my spiel. I like to do the thank you slide. You've got my email here if you want to talk to me about any of this. And I like to put these graphs here because I'm just so pleased with these graphs. Look how big the blue line is. It's much higher than the red or the yellow line.
Yeah. Thank you, Chris. One really awesome, really cool to see. Those speeds are pretty incredible. So it almost sounds too good to be true.
I did make sure my engineers weren't lying to me. Like, we did go through a bit of testing, and like, yeah, when we first created it, it was good but not great. I'm like, yeah, okay, that's about what I expected. And then they're like, oh wait, if we change these config options, let me just check. Chris, I think you're going to want to look at this. I'm like, whoa, yeah, that's cool.
Somebody got a beer out of that one. So, actually, I did have a couple questions that kind of came to mind as I was watching. So I guess the first would be, if you talked about, if I wanted to migrate over, like you deal with those migrations, quite often. But what are some of those challenges I might expect to face if I am going to be migrating? Like if I'm currently on AWS or Google Cloud and want to move to ANF, like what are some things I can expect to encounter?
So if it's Postgres to Postgres, it's remarkably straightforward. We can sort of just set up replication slots on our side. You set your side up to replicate, and then the data starts streaming across. You can then maybe move parts of your app, and so then ours is not write, it's only replicating. So then you can point your app to just read off our side, and depending on the replication, you can make sure that all the data is written to it before you read, or you can just read from maybe slightly stale data. So Postgres to Postgres is really quite simple. That's the easy one. If you want to do something like migrate your Oracle database to PostgreSQL, that's obviously a bit more involved. So if you just want to do Postgres to Postgres, we can just onboard you as part of that. If you want to do Oracle to Postgres, then we get our consulting team involved, and you've got to think a lot more carefully. They're pretty similar, but they're not like ever designed to be similar. Sometimes people have this impression that PostgreSQL is like the open source Oracle, because they do operate somewhat similarly under the hood, but that's like not true, never been true. No one's ever tried to copy Oracle. It's just the Oracle engineers and the PostgreSQL engineers have all been trying to solve the same problem, so they often come up to similar solutions. So there's extensions that can help with that. There's different ways that dates are handled in the two, but you can work around that. And yeah, absolutely, that's a consulting job. That's a migration that you plan for and think about for months before pulling the trigger.
Spot on.
Cool. And then kind of one other sort of question, just a clarifying question. When you're talking about the database forking, right? You said like, hey, I could spin up a new cluster every morning and test my data, or like anytime I need to, that kind of thing. And I just wanted to clarify what you said is like you said, so I'm just pay to spin that up and that's it. Like, am I paying for each new cluster, or am I just paying for like the 30 seconds or so that it's live, or that I'm just using?
Yeah, so we bill by, I think we bill by the minute basically. So you'll pay for the cluster, but if all you want to do is put it in your CI/CD pipeline, run a few queries, and then destroy it. If you run a cluster for 6 minutes, then I don't know what's 6 minutes divided by a month. It's like a fraction of a percent of whatever the monthly cost of that cluster is, and that's all you pay for. So you can do that through the API. You say, I want to create a snapshot and make a fork of it. So you just send that API command. We'll return you an IP address. You query that IP address to your heart's content. You spend 5 minutes running your test suite on it, blah, blah, blah. And then you send the delete command. It's gone. And you get charged for 5 minutes of Instaclustr time, which is that much.
Okay, cool. Yeah, I was curious. Was a little bit clarifying in there, so appreciate that.
Yeah, for sure.
Cool. Yep. All right. Well, again, thank you both so much for your time today. It's just really interesting stuff. And again, you see Chris's email on there, so feel free to reach out to him if you do have any follow-up questions. And I wanted to thank everybody else who joined us and who's watching this. We really, really appreciate you guys being here. Don't forget to check out our website, dzone.com/events. We got a ton of other great stuff up there. We got those on-demand webinars. We've got virtual roundtables, all the stuff we talked about earlier. And also just wanted to mention too, we actually just released a ref card about PostgreSQL from one of our most expert contributors. She's fantastic. She's really, really knowledgeable. And it's a really fantastic resource. So if you do want to learn about all things PostgreSQL, you can check out that ref card on our website as well. That's it for us today. Again, thank you everyone for joining us. Thank you, Chris. Thank you, Will. Really appreciate you guys being here. And we will see everyone next time. Thank you so much.